Okay, in this video, I will be going through the end of year 2020 for the Set 3 Express. I will divide the video according to the pages, so you can skip directly to the pages that you have problem with. Okay, for question 1, actually this is one of the questions that last year Set 3 has the most problem with. The reason is because the readings are all given in mm. However, when you want to select a measuring instrument, normally the measuring instrument, for example, your meter rule and your vernier caliper, we are very used to see the precision in terms of cm. So basically this question is testing whether the candidate, the student, is able to turn this precision in terms of mm instead. So when you want to do that, actually the trick is that you need to keep it to the same number of SF. So for example, when you want to change cm into mm, right? 1 cm basically is 10 mm, right? So technically what you need to do is you just need to multiply by 10 here. So when you do that, you need to keep to the same SF. So down here, when you do that, you will find that your meter rule can only read up to 1 mm. Okay, because your equipment, how defined the scale is. When I say the scale, it means like, for example, your meter rule looks like that, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, so your meter rule can only give you an accurate reading of smallest 1 mm. So because of that, we say that for the meter rule, the precision is 0.1 cm because this is the smallest interval that you can obtain using the equipment. So because of that, when you change the unit from cm into mm, the amount of precision will not change, right? You are just simply changing the unit. You are not improving the scale of the instrument. So because of that, we say that when we want to switch the unit, we will keep the number of SF the same. So when you look at the original precision of the meter rule in cm, you can see that it is 1 SF. Right, this thing over here is 1 SF. So after you switch to millimeter, the precision is still 1 SF. Okay, now if you continue to do that, then your vernier caliper will have a precision of 0.1 mm. And of course, for your micrometer screw gauge, it is already, the precision is usually given in mm, in terms of mm. So once you have worked these precisions out, you can actually tell that a meter rule will be able to give you a 0 dp reading in terms of mm, and your vernier caliper will be able to give you a 1 dp reading in terms of mm, and then your micrometer screw gauge will give you a 2 dp reading in terms of mm. So if you look at the dimensions provided, you can actually see that the first dimension actually is a whole number, so meaning that this is 0 dp, and then the second reading is 1 dp, followed by the third reading, which is 2 dp. This means that the first reading is measured by a ruler, second reading is actually measured by a vernier caliper, and the third reading is actually measured by your micrometer screw gauge. So as a result, what are the measuring instruments that you would need in order to measure this? You actually require all three. Okay, for question 2, it is a straightforward question. I'm not even asking you about zero error. I'm just asking you to read the vernier caliper. So when you deal with such question, you need to be very observant that how many number of sheets of plastic here. So this question, I make it very easy. It is just a singular sheet, so you don't need to divide the reading that you get from your diagram by the number of sheets. So meaning that the answer over here is just a direct reading. Now, what are some common mistakes that students make? So for this part over here, this rectangle, right, is meaningless. Okay, it's there to confuse you. Because what you need to read is this. This is the important part, the black color line. So how to read the main scale? This is the main scale. Okay, this is called the main, this is called the main scale. To read the main scale, you find the scale reading right before the 0 over here. So the main scale like that will be 3.1234, 3.4. And after that, you're supposed to look at your vernier scale. This is your vernier scale. And you should search for the scale that is in line. So in this case, you should read this. And it will be 0.06. So this is 0.00, 0.01, 0.02, 0.03, 0.04, 0.05, 0.06. Yeah, and once you know this, then the combined reading will be 3.4 plus 0.06. That will give you 3.46. The unit is cm. Okay, for question 3 is more or less a recall question. It's either you know or you do not know. So basically, they want you to differentiate whether something is vector or scalar. So here, for the purpose of revision, I will just list down all of them. Acceleration involves direction, so it is vector. Speed is scalar, it can only be positive. Velocity is basically the vector form of speed. Time, unfortunately, as of now, you can only travel forward in time, so we say that time is scalar. Density is made up of mass and volume, both of which are scalar. So because of that, when you take a scalar divided by another scalar, density is also a scalar. Distance is always positive, so there is scalar. It is a scalar. Okay, for question 4, it is about your pendulums. You need to know how one oscillation is defined. So basically, when you want to time one oscillation, we are talking about from the original position, move to the extreme, pass here and back. So this is one oscillation. So in the question, when it is going from X to Y, this is actually 1/4 of an oscillation. So that's the first piece of information that you need. Okay, so down here they are telling you that the time taken when you want to move from X to Y is 0.4. So 1/4 of an oscillation will be 0.45 seconds. Okay, and now you are asked how many oscillation will you make in 27 seconds. So what you can do is you can first find out what is the amount of time taken when you are doing one oscillation, and then after that you increase it to 27 oscillations, and you should be able to find the time.